Good evening, folks. Mr. Vass here. I had a couple questions on the limits and continuous function worksheet that we did in class today. We worked on in class, specifically the questions on the back. For those problems, you had to sketch the graph of a function with the indicated features and write an equation for the function. I've made up two examples here that are similar to the ones that were on the back of the worksheet. I'm going to go ahead and start with the first. I'll start with the graph on the first one. So I'm going to go ahead and set up my x and y axes, and I know that the function has a limit of -1 as x approaches 0 from the right. So as x comes in from this way, I approach -1. So I'm going to simply create a function that does that. So that's going to be 1/2 of my function. The other part I'm concerned with, there is no limit as x approaches from the left. So as x approaches 0 from the left, I have no limit. I'm going to go ahead and sketch something that looks like that. And that this function right here approaches infinity as x approaches 0, and as the function output approaches infinity, we say the limit does not exist. So what does the function look like for this? I'm going to go ahead and create a piecewise definition here. I'm going to start with x greater than or equal to 0, because that's the easy part. Simply, that's -1. That output will always be -1, and that's for this piece of the function right here. For this piece of the function, I'm going to specify the domain as x less than 0, and I happen to know that that graph, or one just like it, can be created with this function, the opposite of 1 over x. And that's all we need for the first one. I have a function that has no limit as x approaches 0 from the left, and a limit of -1 as it approaches 0 from the right. For the second example, I have the function has to have a step or jump discontinuity at x equals 4, and the value of the function when x is 2 has to be 1. So I'm going to go ahead and start with something nice and simple on this one. I'm going to say that I have my jump discontinuity right here. I'm going to jump up to x or to an output of 2 and define that for all values of x greater than or equal to 4. And again, I'm going to do this with a piecewise function. Little typo there, that should be 2. And now I have to think about what happens left of -4. What happens on the left side of -4? Well, the output has to be 1 at an input of 2. So 2, 1 has to be on the graph of this function. I can simply create this by going like this. I'm going to have to put a hole here, and I'll explain that in a second. So for x less than 4, the value of the function is 1. And this is quite simply what we see. We're at 1 all the way until we get to 4, and then we jump up to 2. So we've created the jump discontinuity that was requested here, and I have a function value 2, 1. That's it for this example. I hope this helps. Let me know in class tomorrow.